Hi, this is Amasama, Assistant Professor, SNS College of Technology. Thank you for the previous support towards the videos which I have done in the feedback sensors which are used in robotics based upon the drive systems used in robots. So, as I said, feedback devices are most important and key factor in the robot technology. So, let's start with the presentation, right? This topic is all about the feedback sensors. So, as I said that in order to control the manipulator, the robot has to attain the position and feedback velocity devices, right? So these feedback devices are maybe considered as a position sensor and velocity sensor. By the name itself, we said that position means XYZ coordinates, right? So at what position the robot has been there, and which position it has to work as a one work clump, and where it has to pick a place or where it has to perform the certain task has to be identified with the position sensors. In we are going to discuss about whether the robot movement has to be accelerated or deaccelerated, at what range it has to function has to be identified by using the velocity sensors. So now we are going to discuss in detail about the position feedback sensors. As I said that position feedback sensors are one of the feedback devices which is used to identify the accurate movements of joints for identifying the required direction and the position of the end effectors to do the certain task. The robot requires the velocity sensor for controlling the speed of manipulator movement, and also it has consists of several devices like resolvers, potentiometers, and encoders for including DC tachometer for providing the appropriate speed. So this is how as I said, this is a circular where welding robot or manufacturing robot has been developed. So how it has been working as to be identified by using these type of sensors. So when we go for first and position feedback sensors, is encoders. So normally everybody knows the encoders are used for converting the angular or linear displacement into digital signals. So some of the type examples of encoders are linear encoders. Second one is rotary encoders. Third one is an incremental encoders and absolute encoders. From the name itself, we can able to understand that linear is an linear form of motions, like in the x-y axis. While rotary encoders helps to calculate the directions and also the positions which are in angular form. Examples, the motors. So incremental encoders is just a little bit like in linear encoders. It is used to sense the position at which position it is present with compared to its last position. But in absolute encoders, it is able to bring its definite position is proportional to its fixed reference position. This is how the encoders has been working, and the different type of encoders has been listed out. And then we are moving towards potentiometers. So the potentiometers produce an output voltage that is proportional to the position of the wiper in the medicines. So these are they are the analog devices used for calculating a linear or rotary movements. Based on the design which are given for robotic systems, and also it consists of a rotating wiper. The wiper is then connected with an object when it is in motion. An AC or DC voltage is supplied to the resistive element. So the wiper and the ground is always become proportional to the ratio of the wiper one side or resistance to give the resistment elements into a total resistance. So example for that picture I have shown in this picture about the potentiometers, and now finally we are moving about resolvers. Everybody's roles resolvers as an analog device like an potentiometer, and it is on a rotary electrical transformer basically implemented for calculating the degrees of rotation. It requires only AC signal for excitation because of the DC current will not produce any output signal. So we need only an AC extraction. So the output signal of the resolver is proportional to the angle of rotating element with respect to the fixed elements. This is when I say that this is how the position sensors has been playing a vital role when compared to the other systems because of their valuable supports, and also when I say to that, these position sensors plays a vital role to identify where the robot arm is there and which area it has to work and where the envelope has been there, and where the work envelope of the robot, and where should it has to be act upon that are received by using these position sensors. Hence, without the position sensor, the robotic drive systems cannot be act upon that. So it is one of the key features in robotic systems where they are more important than important in manipulators. So that's the session about position feedback. In the next video, we are going to discuss about the velocity sensors. Till that, bye bye. This is Amasam, Assistant Professor, SNS College of Technology. Thank you for watching the video. If any queries, you can mail me. Thank you. Thank you so much.